All right, for homework 31, we're starting off with just a couple of pre-calc things to practice. So solve for x. 10 to what power equals 1,000? So x equals 3. And 10 to what power equals 1/10? That would be x equals -1. So logarithms, remember, are equal to exponents. You're just trying to figure out what exponent do you raise the base to get the result. For this problem, illustrate the functions or inverses of each other by sketching their graphs. So for 4 to the x, there's a horizontal asymptote at 0. When you plug in 0, you get 1. And when you plug in 1, you get 4. If you plug in -1, you get 1/4, if you want to plot that. But here's the general 4 to the x graph. So I'm just going to label that F. And then for log base 4, the nice points for a log graph are 1, 0. It has a vertical asymptote at x equals 0. And 4, 1. And so this has this general curvature. So yeah, these are inverse functions. They have that reflection across the line y equals x. So yeah, they look like inverses to me. Find the derivative of the function. In some cases, you may have Reed definitely will find it helpful to apply log properties before differentiating. So that's just if you're differentiating with respect to logs. So 54 will be the first one that we look at that for. All right, otherwise, what's our rule here? So the derivative of a general exponential is the general exponential multiplied by the natural log of that base. So 4 to the x times natural log of 4. If there is a u, make sure that you chain rule. So f prime of x, the derivative of 3 to the u is 3 to the u times the natural log of the base times the derivative of u, which is 2. Excuse me. For the next one. So we have a product rule here. So we have to make sure that we remember to use product rule to begin with. So h prime of theta is equal to first times derivative of the second. So we're going to have to chain in both of these here. So derivative of cosine is negative sine of pi theta. And then I need to remember to multiply by the derivative of pi theta, which is pi, plus second times derivative of the first. So 2 to the negative theta, natural log of 2. And then the derivative of negative theta is -1. So looking at what we have here, I want to clean this up a bit. So let's make this negative pi sine of pi theta. And then instead of times 2 to the negative theta, let's just put over 2 to the theta, just so that's not so cluttered. And then I'm going to do the same thing here. So minus natural log 2, that's that part, times cosine of pi theta over 2 to the theta. And yeah, I could have said I'm factoring out a 2 to the theta, or put these all over the same common denominator. There's nothing really, maybe a negative, I guess, to factor out of the top, so I'm just going to leave it like this. All right, so that's my answer for 49. All right, now we don't have any rules for logs, for derivatives of logs that are not base e. So in other words, we only have natural log rules, right? So the first thing we need to do is work on this a little bit to get it in terms of natural logs. So using change of base formula, the log base 2 of this result is the natural log of the result over the natural log of the base. And you can still use a little bit of expansion here to begin with. So first of all, 1 over natural log 2, that's just a constant. So sometimes I pull it out so that I don't think of it as like a quotient rule or anything. And then remember, this exponent in a logarithm can get multiplied out in front. So really we have a 3 that's out in front here. 3 over natural log 2 times natural log of t squared plus 7. Now there's no way to break that up any further or expand, but now we can take the derivative here. So g prime, this is all g of t, by the way. So g prime of t, the 3 over natural log 2 is still out there. The derivative of this natural log is 1 over t squared plus 7 multiplied by the derivative of t squared plus 7, 2t. So just cleaning this up a bit, I have 6t on top. I have natural log of 2, and you would need parentheses around t squared plus 7. So there's g prime. Same thing with 54. We're going to need a product rule, but before we do that, we need to work on this log. So let's rewrite f of t. So t to the 3/2 has to stay. Let's make this times the natural log of the square root of t plus 1 over the natural log of 2. And then let's take care of this as well. So t to the 3/2 times 1/2 natural log of t plus 1 over natural log of 2. And let's get our constant out in front so we don't have to think about it too much. So 1/2 over natural log of 2 is just 1 over 2 ln 2 times t to the 3/2 times ln t plus 1. All right, so this constant is just along for the ride when I find f prime. Excuse me. And then I'm going to have to do a product rule right here. All right, so 1 over 2 ln 2. I'm just going to put that outside of braces so that I don't forget about it, or so I remember to distribute it through. All right, so first times derivative of the second. So this will be 1 over t plus 1, and the derivative of t plus 1 is 1. And then plus the second times the derivative of the first, so that will be 3 over 2 times t to the 3 over 2 minus 2 over 2 is 1 over 2. So this is 1 over 2 ln 2 times, looks like we have t to the 3/2 over t plus 1. And then here I have like t to the 1/2, let's see, 3 t to the 1/2 ln of t plus 1, then it would just be over 2. I'm not going to work on simplifying this too much because we're not doing anything with these. We're not setting it equal to 0, so I don't want to spend too much time simplifying this, but I could factor out a t to the 1/2 and probably set up a common denominator or something, but we'll just leave it at that. All right, for this one, find an equation of the tangent line at the given point. So we need a point, which we were given, 2, 1, and we need a slope, which will be finding y prime and evaluating it at 2. So let's find y prime first. So dy dx is equal to 5 to the x minus 2 times natural log 5 times the derivative of x minus 2, which is 1. And then evaluate dy dx at the ordered pair 2, 1. So we're putting in 2 for x. So that becomes 5 to the 0 times natural log 5. And that's just natural log 5. So now write the equation of the tangent line. So point slope form y minus 1 equals slope natural log 5 times x minus 2. For the next one, this is log base 10 of 2x. So first we need to work on y. It's actually the natural log of 2x over the natural log of 10. And remember, we can expand this a bit. We don't have to expand it, but this would become, let's make it 1 over natural log 10. And then it could become natural log 2 plus natural log x. That's just expanding that out. The nice thing about that is it'll make the derivative even easier. I won't have to chain rule. We have a point, 5, 1. We need a slope, so we'll find y prime and evaluate it at 5. All right, so y prime. So the 1 over natural log 10 is here to stay. The derivative of natural log 2 is 0, and the derivative of natural log x is 1 over x times 1 technically, and y prime at 5 is then equal to 1 over 5 natural log 10. All right, so y minus 1 equals 1 over 5 natural log 10 times x minus 5. So that was all derivatives. Now we're switching over to integrals. So find the integral. Remember, it's best to split these into separate terms. You don't have to do it this way, but if you get confused, especially when u sub is involved, it's a good idea to split things up. Split up your terms. Okay, so this part's easy. This is x to the 4th over 4. But then this part needs a little bit of work. So let's see. U would equal negative x. Du dx would equal negative 1. Negative du would equal dx. So to set up this u sub, I'm going to have 3 to the u. Instead of dx, I'm going to have negative du, so I'm just going to put the minus out here. All right, so that's x to the 4th over 4 minus the integral of 3 to the u du is 3 to the u divided by natural log 3 plus c. And then in place of the u, I'm putting the negative x back in. If this is 3 to the negative x, let's just send it down here. So natural log of 3 times 3 to the negative, not to the negative x anymore, 3 to the x plus c. That would be my final answer. All right, because remember I find that people forget about the whole divided by natural log of the base thing because we started learning this with e and we didn't have to worry about that since natural log e is 1. So anyway, just be wary of that. Now this one I can't split into like an integral times an integral, but the fact that these are similar parentheses is your hint about u sub. So we're going to let u equal 3 minus x, the quantity squared. So du dx would equal 2 times this quantity, 3 minus x, times the derivative of 3 minus x, which is negative 1. So du divided by negative 2 times 3 minus x should equal dx. So if you set up your u sub like this, you should get this 3 minus x to cancel. So this is 3 minus x times 7 to the u. And then in place of dx, we're putting du over negative 2, 3 minus x. So yeah, the 3 minus x is canceled. Let's bring a negative 1/2 out in front of the integral. So this is negative 1/2 times 7 to the u. So I'm going to say 7 to the 3 minus x quantity squared divided by natural log of 7 plus c. I'm not going to work on simplifying that, just in interest of time. All right, for the next one, I'm going to let u equal the denominator, 1 plus 3 to the 2x. And then du dx would be 3 to the 2x times natural log of 3 times 2. And that means that du divided by 2 ln 3 to the 2x would equal dx. So if you want to set all of this up, you can. If you're getting into a place where you can kind of see, okay, that's going to cancel with that, and I'll just put the constant out, that's great. I just feel like we might not all be there yet, so I'm just going to keep showing this the detailed way. So yeah, 3 to the 2x's cancel. I'm going to pull the constant out, 1 over 2 ln 3 times the integral of 1 over u du. So the constant is out there. The integral of 1 over u is natural log u, so times natural log absolute value 1 plus 3 to the 2x plus c. For 82, I should let u equal the exponent for this one. du dx is equal to cosine x. Du over cosine x is equal to dx. Set up what you have. You have the integral of 2 to the u times cosine x, and then dx is du over cosine x. So those cancel. Oops, that should be a du. So we have the integral of 2 to the u du, and that's 2 to the u, so 2 to the sine x, divided by natural log of 2 plus c. Evaluate the integral. So for this one, opening my calculator because I just saw that I've got some more problems down there. For this one, same idea, but we're just evaluating. So no u sub needed here. The integral of 2 to the x is 2 to the x, 2 to the x divided by natural log of 2, going from negative 1 to 2. So 2 squared is 4 over ln 2 minus 2 to the negative 1 over ln 2. So they're both over ln 2. 4 minus 1 half is, not 3 halves, whoops. 4 minus 1 half would be 3 and a half, so I almost wrote 3 halves. So 8 over 2 minus 1 over 2 is 7 over 2, goodness. So I'm going to make this 7 over 2 ln 2. Now you could use logarithm rules to condense this and make it 7 over ln of 2 squared. So it could be 7 over ln 4. I'm not sure if I did that in my answer key, but you only have to do that if you're trying to find equivalent answers in multiple choice. We need a little bit of u sub here, so u is equal to x over 2. Du dx is equal to 1 half. That means that 2 du is equal to dx. So this is going to be the integral from negative 2 to 2 of 4 to the u. Instead of dx, it's 2 du, so I'm going to put the 2 out here. That's equal to 2 times 4 to the x over 2. There's no negative there, sorry. 4 to the x over 2 over ln of 4. And we're going from negative 2 to 2. All right, so when you plug in 2, you get 4 to the first over natural log 4. Minus, when you plug in negative 2, you get 4 to the negative first over ln 4. So we can take our ln 4 out. 4 minus 1/4 is 15/4. And that could be 15 over 2 ln 4. For this problem, we've got application here. So if the annual rate of inflation averages 5% over the next 10 years, the approximate cost of goods or services during any year in that decade is P times 1.05 to the T power, where T is in years, P is the present cost. So the price of an oil change for your car is presently, there's P, 24.95. Estimate the price 10 years from now. So this is if inflation is 5%. All right, so this would be C of 10 equals 24.95 times 1.05 to the 10th power. So this is not really, no calculus involved at the moment. Raising that to the 10th power. I'm going to round this to 2 places because we're talking about a cost. So $40.64 in 10 years. Find the rates of change of C. So there's the calculus with respect to T when T equals 1 and T equals 8. Now, if we're allowed to use a calculator, don't overthink it. Even though you could find the equation for C prime, don't waste your time doing that. Just find C prime. So math 8x 24.95 times 1.05 raised to the x power. And we want to evaluate that when x is 1. So this is $1.28. And C prime of 8 is the same thing, second enter, and just change this to 8. 1.80. if I had to label those, it should be, I put in the dollar amount, it should be that dollar amount per year. So the cost of the oil change is increasing at $1.28 per year or $1.80 per year. Verify that the rate of change of C is proportional to C. What is the constant of proportionality? So what they mean by this is show that C prime of T is equal to some constant, we'll call it K, times C of T. All right, so let's go ahead and find C prime of T. So the derivative with respect to T of 24.95 times 1.05 to the T power, that derivative is equal to 24.95 excuse me, times 1.05 to the T divided by natural log of 1.05. And that's supposed to equal some K times C of T, which is 24.95 times 1.05 raised to the T power. So yeah, there's a constant here. The constant is 1 over ln of 1.05. That's the constant of proportionality. The C prime equation is the C equation, just with some extra constant out in front. The yield V in millions of cubic feet per acre for a stand of timber at age T is this. T is measured in years. Find the limiting volume of wood per acre as T approaches infinity. So find the limit as T approaches infinity of 6.7. This is a negative exponent, so I'm going to write it over e to the 48.1 divided by T power. As I put in infinity for T, this is going to equal 6.7 over e to the 0, because 48.1 divided by infinity is practically 0, and that's just 6.7. This is measured in millions of cubic feet per acre. Part B says find the rates at which the yield is changing when T is 20 and T is 60. So again, if we can use a calculator, which I'm saying we can, we're not going to show any work for this. We're just going to do the equation. So math 8, derivative with respect to x of 6.7 times e to the negative 48.1 divided by x. Evaluate when x is 20. So split here. So 0.073. What would the measurement be in this? So this is millions of cubic feet per acre and then per year. So millions of cubic feet per acre. That's the measurement for V per. I'm going to write the word per because I don't want to have another divided by per year. And then same question, but you're just changing 20 to 60. So second enter and then change 20 to 60. 0.040. So V prime of 60 is about 0.040. Same label. Millions of cubic feet per acre per year. All right. On our short quiz tomorrow, lots of integrals and derivatives like you just saw here. So if you have questions on any of these, please plan on coming into office hours in the morning. All right, that's it.